We have already looked briefly at the introduction section of the Jeppesen manual. In this lesson, we shall look in more detail at those pages dealing with the en route chart legend, starting on page 52. Some of the symbols shown in this section are printed in green. These are also printed in green on two-coloured charts. On single-coloured charts, all symbols are printed in blue. For this lesson, each page will be shown to you on the screen. Only those symbols relevant to your examination will be shown. Click on the symbol starting at the top left-hand column. When you have understood the explanation, click on the next symbol down and so on. From the bottom of the column, go to the top of the right-hand column. At the end of the page of symbols, click the forward arrow to continue to the next section. We shall start at the Navaid section on page 52. Most of these symbols have to be committed to memory. Start with the symbols for VOR, shown at the top left-hand column. These are the symbols for the instrument landing system and microwave landing system, called ILS and MLS respectively. It is important to note that the presence of a localizer does not necessarily imply that the glide path information is also available. This can only be determined by reference to the terminal charts, which we shall look at in a later lesson. The upper section on page 53 shows how navigation aids are identified on the chart. The first symbol shows how navigation aids associated with an airway are displayed. This is known as a shadow box. Within the box is shown the name of the facility, its frequency, identifier, and Morse code. In addition, it may show a small d next to the frequency, indicating that it is a frequency paired with the DME. The operational coverage of the beacon may be shown by a T for terminal, L for low altitude, and H for high altitude. The next symbol shows the shadow box for Kadena. It has printed under the box its geographical coordinates. This is used on high-low altitude en route charts when the facility is part of the airway or route component. Finally, in this column, the shadow box for Benbecula indicates that the DME and VOR are not co-located. When you are ready, go to the next section entitled Communications, which starts on page 53. When voice communication is available through the Navaid, the frequency is shown above the box. Frequencies in the 120 MHz range are abbreviated by removing the 1-2 part of the frequency. Thus, 122.2 is shown as 2.2, and 122.35 is shown as 2.35. HF and LF frequencies are not abbreviated. Once you have understood this, turn to the top of page 54 for the continuation of this section. The call sign and frequencies of air traffic control areas are shown within a box outlined by telephone handset symbols. In this example, the call sign is Manila Control, and the frequencies are as shown. The next symbol is for stations broadcasting plain language weather forecasts and gives both its call sign and frequency. In the right-hand column of Navaid communication data, the shadow box for Saarbrücken has its identifier SBN underlined. This denotes that the beat frequency oscillator must be switched on in order to hear the Morse identification. Below the shadow box is an asterisk. If an asterisk is placed beside the facility name or frequency, this indicates that the service is not continuous. The boundaries of restricted airspace are outlined with a hatched lined border. Training, alert, caution, and military operations areas are outlined with a wider hatched line as shown. Within the outline, as shown by the next symbol, the type, identification, upper and lower limits, and hours of operation are tabulated as shown. A dot next to the restricted airspace identifier indicates that the area is permanently active. The letters indicating the type of airspace are shown at the top of page 55. The symbols denoting both civil and military airports, seaplane bases and heliports are shown on page 55. These are fairly self-explanatory. Airport elevations are shown in feet above mean sea level. Airport names in initial capitals denote that the airport does not have a Jeppesen approach chart, whereas airport names in capital letters indicate that there is a Jeppesen approach chart for that airport. Where there are two names, the chart is filed under the name that is in capitals. When you are ready, move to the next section entitled Airway and Route Components. This section contains a great deal of information, some of which you will not require for the examination. Therefore, we have not made it available to you in this lesson. Starting at the top of the left-hand column, we see that airway route centerlines are marked by a solid blue line, whereas a weekend route, as used in some parts of Europe, are marked by a dashed blue line. Compulsory and non-compulsory reporting points are similar to those we have seen in the VFR chart. Compulsory are solid triangles, and non-compulsory are open triangles. En route holding patterns are as shown. The first figure indicates the DME distance of the start of the hold, and the second figure is the outbound or inbound limit. In this example, D31 is the distance of the fix, or the start of the hold. The inbound turn is then commenced at the second distance of 39 nautical miles. The position of reporting points is shown as intersecting radials from two VORs. If the VOR is remote or off the chart, its frequency and identifier will be shown. En route reporting points are identified by their distance from a DME beacon. In the examples shown, the first reporting point is 12 miles from the DME. The second is a further 10 miles, making a total of 22 miles from the beacon. Again in this scene, click on the relevant symbol to hear the explanation. When you are finished, click the forward arrow to continue. An Airways designator is shown within a box on the center line of the airway. The example shows airway Alpha 1. If the box has an arrowhead, this signifies a one-way airway in the direction of the arrow. Alpha 5 is a one-way airway in the direction of the arrow. Some routes show minimum and maximum usable altitudes, and these can easily be confused. Careful note should be taken of the following. Minimum en route altitudes, MEAs, are 4-figure numbers printed along the alignment of the airway. They may be directional, as shown in the example. Minimum obstruction clearance altitude, MOCA, is a 4-figure number followed by the letter T. Minimum off-route altitude, MORA, is the figure followed by a small letter A. The maximum authorized altitude, MAA, is denoted by the letters MAA, followed by an altitude or flight level. The first figure in the right-hand column shows how the total mileage between consecutive Navaids is shown as a figure in an hexagonal box. This is the sum of each of the segment distances shown in plain figures along the airway. It is common practice to use the Navaid at the point of entry of a route to define the centre line. At some point along the route, it is often expedient to change over to the Navaid at the destination end. This is marked by a changeover point showing the distance from the departure Navaid and the distance to the destination Navaid. Some airways, for convenience, use non-standard flight levels. A capital letter E with an arrow indicates that in that direction even flight levels are used and odd flight levels in the opposite direction. This would be contrary to the accepted rules of even and odd flight levels. Similarly, a capital letter O may be used on one-way airways to indicate that odd flight levels are to be used. Now go to page 57. You are strongly advised to spend some time studying the diagram on this page and identify the symbols we have described in this lesson. If you are unsure of the meaning of any of them, refer back to the pages we have covered. Further explanations, if required, can be found in the glossary of terms and the abbreviations.